Okay, in this video, kids, we're going to talk about finding the area of triangle. All right? And in order to get started on this, we're going to talk about some background information. Finding the area of a triangle and the formula for finding the area of a triangle are very closely related to finding the area of a parallelogram, square, or rectangle. We can say this because a decomposed parallelogram, square, or rectangle will give us triangles. Okay? And so let's look at some of these examples down here. All right? So let's say that this parallelogram has a base of 3 centimeters, and then we'll give it a height of 2 centimeters. We could then use the formula of base times height to find its area. Well, of course, the base is 3, the height is 2, so the area of that parallelogram is going to be 6 square centimeters. All right? But how does that relate to triangles? Well, it relates to triangles because if we were to divide that in half from vertex to vertex, either way, we would get 2 triangles. Each of these triangles then would be half of that total area, which means that this triangle would be worth 3 square centimeters, and this triangle would be worth 3 square centimeters as well. All right? So we know that one triangle formed from this parallelogram would be half the total area. And the same with this square. If we knew that the one length of this square was 5 centimeters, all right, we know that the total area would be 5 times 5, which is 25. But if we only want half of that in the form of a triangle, we know that half of 25 is going to be 12 and 5 tenths, or 12 and a half square centimeters. And so each side would be half of that total area. And the same would apply for a rectangle. If you can figure out the total area of a rectangle, such as this one, would be 24. And if you only wanted half, you could divide it by 2, and you would know that the area for each half would be 12. Okay? And so that's how decomposed parallelograms, squares, or rectangles will give us the area of triangles. All right? Let's take a look at the actual formula. The formula for finding the area of a triangle is area is equal to 1/2 times base times height. So it is read, the formula is read like this. The area of a triangle is half, okay, so the area of a triangle is half of the base, of meaning multiplying, half of the base times the height, which is the last operation. All right? So if we were to actually take this formula and see it used, we would look at our example here. So we have a height of 6 centimeters and a base of 4 centimeters. Okay? A base of 4 centimeters. And we would just take those values and plug them in to our formula. So our base is 4, our height is 6, and then we would just follow the order of operations, and the first thing that we would do is we would multiply 1/2 times 4, and that would give us 2. So the first thing we do is 1/2 of the base is 2. The second thing that we would do we would take this product, which is 2, and we would multiply it by the height, which is 6. So we would do 2 times 6, and we would get an area of 12 square centimeters. And this makes a lot of sense if you consider that this started out as a rectangle, if you want to think of it that way. And if you had this rectangle and you wanted to know the area of that whole rectangle, you of course would do 6 times 4, which is 24. But we don't want a whole rectangle. We only want half of a rectangle. And half of 24 is 12. And that's why we start out multiplying by a half. And then we do the rest of the math, okay? Because we're only going to want half of base times height. All right? So, anyways, why don't we try some example problems now? Try some of these example problems. See if you can find the area for this triangle. Pause the video and see how you do. All right, let's take a look at the answer. The area for this triangle is 15 square meters. And if you did the math, your math would look like this. First thing that we want to do is we want to plug in the known values to our formula. So we are going to take the base, which is 6, multiply it by a half, times the height, which is 5. Okay? So the first thing that we will do is we will multiply 1/2 times 6. Half of 6 is 3. And then that will multiply our height. And so we will multiply 3 times 5 is 15. So the area of this triangle is 15 square meters. And if we thought of it as a parallelogram, that would make sense, wouldn't it? Because the area of a whole parallelogram, in this case, not a very good parallelogram, would be 5 times 6 is 30, but we only want half of that, so that would be 15. Alrighty? Try finding the area of this triangle. Pause the video. Alright, let's see how you did. The area of this triangle is 56 square inches. And the way we came up with that would be we plugged in the known values. Our base is going to be 8. Our base is 8, so we're going to use this line segment as our base, times our height, which is 14, and then we do the math. Well, 1/2 of 8 is 4. So now we have 4 times 14. And that's not one of our quick facts, so you might want to take and say, okay, what is 4 times 14? If you can't do it off the top of your head, 4 times 4 is 16. Carry the 1. 4 times 1 is 4, plus 1 is 5, so we have 56. And indeed, that does match our answer. So we did half of the base, which is 4, times the height, which is 14, and that gives us 56. An area of 56 square inches. See if you can solve this problem. Pause the video. Alrighty, let's see how you did. The answer to this problem, what is the area for a triangle with the following coordinates? The area would be 12 5/10 of a centimeter. And the way you come up with this is you would plot your points, okay? And you may have had to actually sketch out your coordinate plane, but they gave us one here on the problem on the video. And what you want to remember, though, is that the distance of one square is 1 centimeter. So you'd want to first of all think, okay, where are my points on the coordinate plane? Our first point is -4, +3. Second point is -4, -2. And our third point is +1, +2. So there are the 3 vertices of our triangle, and then you'd want to draw in your lines, and now we have the shape of our triangle. Alright, now in this case what we'd want to do is decompose our triangle so that we have easier shapes to work with. Or we could just say, okay, this is going to be my base, and I have 1, 2, 3, 4, 5 as my base. My height is going to be established from a perpendicular line from here straight up, and so my height is going to be this distance. It would be 1, 2, 3, 4, 5. So if we were to think of our height, we could just measure it out like this and say our height is going to be 5 centimeters. Okay? Well, now all we have to do is plug in our numbers into our formula, and we know that we are going to want 1/2 of the base, which is 5, times the height, which is also 5. Okay? And if we multiply 1/2 of 5, we will get 2.5 times 5. And then, of course, if we multiply 2 and 5/10 times 5, we can come over here and we can actually do that math if we can't do it in our head. All right? So we know that 5 times 5 is 10. Regroup your 1. I'm sorry, 5 times 5 is 25. Regroup your 2. 5 times 2 is 10 plus 2 gives us 12. I totally screwed that up. And it's a good thing I did. Okay, why don't you give this problem a try? You might have to sketch out the coordinate plane in order to do it. Pause the video. All right, what is the area for a triangle with the following coordinates? Well, the answer to this question, or this problem, is 12 and 5/10 square centimeters. Now, in order to solve this, what you'd want to do is you'd want to either use absolute values and figure out the math in your head that way, which would be kind of tricky, or sketch it out on a coordinate plane. Now, over here, they've given you the coordinate plane, but be careful in a situation like this, because they're telling us that the distance of one square from side to side, up and down, okay, is 1 centimeter. So remember that each one of these squares is a square centimeter. All right, so let's find our points. -4, +3. -4, -2. -4, -2. +1, +2. +1, +2. So now we have the vertices of our triangle, and we can just fill in the lines. So there's our triangle. Now what we want to do is establish a base and a height, because our formula for finding the area of this triangle is going to be 1/2 base times height. So in order to solve that, we have to establish which is the base and which is the height. All right? So let's come over here and say, well, we could use this as a base, but if we look at the way the lines fall in the triangle, we can see that this vertex actually goes right down perpendicular to this line segment. So this line segment right here is going to make a very nice base. So we're going to say that the base of the triangle is 1, 2, 3, 4, 5 centimeters. So we have a base of 5 centimeters. Well, now what we're going to do is we're going to establish our height. We're going to use this line, this perpendicular line from the base right up to this vertex as our height. And so we can count 1, 2, 3, 4, 5 centimeters high as well. Okay, because this is a 90-degree angle with our base. So now we know the dimensions of our triangle in terms of the base and the height. All right, so let's just plug in our values. So we're going to do 1/2 times the base of 5 times the height of 5. All right, so if we do that, we know that the area will begin with 1/2 of 5, which is 2 5/10 times 5. And then, of course, if we multiply 2 5/10 times 5, we might have to do that over here because that's definitely not a quick fact. And so we multiply out our math. 5 times 5 is 25, carry the 2. 5 times 2 is 10, plus 2 is 12. Decimal point over 1, in 1. And you can see that our area is indeed going to be 12 5/10 square centimeters. All right, so that's how we would solve it. When you get a problem like this, just make sure you establish a base and a height that is perpendicular to the base and meets one of the vertices. See if you can solve this problem. Pause the video. Okay, let's see how you did. The area of a triangle is 42 square centimeters. The triangle's base is 6 centimeters. Find the height of the triangle. Explain how you do it. All right, well, the first thing you want to do is ask yourself, what do I know and what is this asking? Well, it's telling us that we have a triangle that has an area of 42 square centimeters. So what we have is, if we sketched it out, we could say we've got ourselves a triangle with an area of 42 square centimeters. Okay? And we know that the triangle's base is going to be 6 centimeters. What we don't know is the height. Okay? So how would we solve this? The best way to solve it would be you would substitute the numbers you know into the formula and then solve for h. So the first thing that you would do is take the formula and we would plug in what we know. Well, we know the area is 42. We know that the base is 6. What we don't know is the variable of the height. Okay? So now all we have to do is get h by itself, and then we know the value of h. So we're going to multiply 1/2 times 6 to give us 3. So that gives us 3h. 3 times h equals 42, or 42 equals 3 times h. But we still want to get this h by itself. So this is a multiplication operation. So in order to isolate the variable, we're going to undo what we've done using division. Okay? So we're going to use the inverse operation of multiplication, which is division. And we're going to have to divide both sides by 3 because we're multiplying by 3 over here. So we're going to isolate the variable by dividing by 3. So 42 divided by 3 is going to give us 14, and then 3 times h divided by 3 will leave us with the value of h. And so we can see that our height in this case should be 14 centimeters. Now, what I always like to tell kids is if once you have found the value of the unknown, go back and check it. All right, so take your formula and plug in the values. So what we've discovered is our height should be 14, and so we're going to put it into our formula. 1/2 of 6 is 3. So we have 1/2 of 6 is 3. Our height is 14. 3 times 14 is indeed 42. So what we discovered over here when we isolated the variable as 14, we isolated the variable and came up with 14. When we plugged that height into our formula, the math worked out, so we had 42 square centimeters. All right? If you have any further questions, you can see your teacher. You can reference your book or ask your parents for help.